Well, there's something very interesting with parallel and perpendicular lines in analytical geometry. Okay, so that is what we are going to discuss in this lesson: parallel lines and perpendicular lines. Okay, let's start off with perpendicular lines. Now, let's say I have two lines on the Cartesian plane. In the Cartesian plane. So let's call these lines, let's call this one, let's just call it line 1. Line 1, straight line 1. It is line AB, and then let's call the second one line 2 with ends C and D. So when the lines are perpendicular, right? So let's say maybe we drew a straight line AB and drew another straight line CD. Then we took a protractor and measured the angle between A and D. Then we found out that the angle is 90 degrees. What can be concluded about these two lines is that when we take the gradient for line AB and multiply it by the gradient of line CD, their product gives us a -1. Always. You have two perpendicular lines on the Cartesian plane. When you calculate the gradient for line AB and then you calculate the gradient for line CD, the product, when you take the gradient for line AB and multiply it by the gradient for line CD, you should always get a -1. That is the special thing or the special property about perpendicular lines. Okay. Now let's also talk about parallel lines. Parallel lines. Say maybe I have two lines. Of course, they don't have to be slanted like this every single time in order to be parallel lines. You can also get them in this arrangement. Okay, you can also get them in this arrangement. So I have line AB, C, D. We say these two lines AB is parallel to CD. Then I also have another AB line and a CD line. When these lines are said to be parallel to each other, we say that for any pair of parallel lines, their gradients are always going to be equal. So say for line AB, the gradient for line AB is going to be equal to the gradient for line CD, provided that the lines are parallel. If you are told that the line AB is parallel to CD, for parallel lines, their gradients are always equal. So even here, gradient AB is also going to be equal to gradient CD. So for parallel lines, the gradients are always equal. Okay. Now let's take this down and perhaps, I don't know, take some examples. Okay. So let's have this Cartesian plane and discuss the following. So they want us to calculate the gradients for line AB and CD. So in each case, we should state whether AB and CD are parallel, perpendicular, or neither. Okay, so let me plot all these points AB, CD, right? I'm going to use a blue for this one. So it's 2 and -1, 2, -1, that's coordinate A. It's 2 and -1. And then we have B, which is 5 and -3. 5 is here. 1, 2, 3, -3. That's point B. That's point B, 5 and -3. Then we also have C, 1, -1 and 1. Interesting. Okay. So C is minus 1 and 1. And then D minus 4, 1, 2, 3, minus 4 and 3, 1, 2, 3. These guys. Okay, D, that's minus 4 and 3. So they've asked us to do what? To calculate the gradient for AB, and the gradient for CD. So I think you can tell from the sketch that they are not perpendicular, nor are they parallel, right? Nor are they parallel. So the answer should be neither here. So, but what I want us to do is to perhaps work out their gradients as stated. Yeah? So we're gonna do this. So we're gonna say gradient AB. Let's calculate it. So it's YA minus YB over XA minus XB. What is YA? That's negative 1. Minus what is YB? That's negative 3. Divided by XA, that's 2. Minus what is XB? That's 5. So the answer, minus 1 plus 3, that's a plus 2 over a negative 3. So this is our answer for gradient AB. Let's calculate gradient CD as well, as stated. So YC minus YD over XC minus XD. What is YC? YC, it's 1, minus YD, that's 3, over XC, that's minus 1, minus what is XD? Minus 4. Numerator, minus 2, and then the denominator, it's going to be a positive 3. So this is our answer. Gradient CD is equal to that. So we can see that gradient AB is not equal to gradient CD. So they are not parallel. And then we can also see that when I take the gradient of AB and try to multiply it by the gradient of CD, let's see what happens. 2 over negative 3 multiplied by a negative 2 over 3. I'm getting a positive 4 over 9. So this is not equal to 1. So since this multiplied by that is not equal to minus 1, so it means that the lines are not perpendicular as well, right? Perpendicular. Let's take just one more example. I have B. Let's answer B. Okay, but this time I don't want to plot the coordinates. Okay, so I'm just gonna go straight to calculating the gradient between AB and the gradient between CD. Okay, so let's start off by finding gradient AB. So it's YA minus YB over XA minus XB. YA 2, YB negative 2 over what is XA, that's 4, minus what is XB, negative 1. So we're going to get a 4 as the numerator and a 5 as the denominator. And then let's do the same thing for CD. Work out the gradient XC and XD. YC, that's 0, minus YD, that's minus 10, over XC, that's 2, minus XD, that's going to be 10. 0 minus negative 10, that's a positive 10, over 2 minus 10, that's minus 8. So a 10 divided by a minus 8, it's a negative 5 over 4. Okay, so since the gradient AB is not equal to CD, they are not parallel. They are not parallel. They are not parallel. And let's see if CD multiplied by AB. Let's see what gradient CD multiplied by gradient AB gives us. So the gradient for CD, that's minus 5 over 4, multiplied by the gradient AB, that's 4 over 5. So when we multiply this, gives us a minus 1. So therefore we conclude that these two lines are perpendicular. Therefore CD is perpendicular to AB. Okay, so this concludes our lesson on parallel and perpendicular lines. Okay, so parallel lines, the gradients should be equal. Perpendicular lines, when we multiply the gradients for the lines that are perpendicular, we should be getting a minus 1. I hope you enjoyed. I hope you got something out of this discussion. I'll see you on the next one. Bye bye.